Hello everyone, my name is Dr. Paripatsi Sombun. I am an instructor from Information Technology Program, Faculty of Science and Technology, Nakhon Pathom Ratchapat University. Today, we are going to learn the fundamentals of visual computer programming. Lesson 5, Creating Animated Apps. In this lesson, we will learn about the canvas coordinate system, how to add a canvas to an app, how to animate objects with the clock timer, and how to detect object collision and edge reached. Moreover, we will learn how to create an interactive animation and specify sprite animation without a clock timer in an app, building by App Inventor. Let's get started. In this lesson, we will learn about the canvas coordinate system, how to add a canvas to an app, how to animate objects with the clock timer, and how to detect object collision and edge reached. Moreover, we will learn how to create an interactive animation and specify sprite animation without a clock timer in an app, building by App Inventor. Let's get started. In this section, we'll take a look at the canvas coordinate system. A drawing on a canvas is really grid of pixels, where a pixel is the tiniest possible dot of color that can appear on the screen. Each pixel's location is defined by x and y coordinates on a grid system. In this coordinate system, first, an x coordinate defines a location on the horizontal plane, starting at 0 on the far left and increasing as we move to the right across the screen. And y coordinates defines location on the vertical plane, starting at 0 at the top and increasing as we move down the screen. Let's take a closer look at the figure. The top left cell in the canvas starts with the 0 for both coordinates. So this position is represented as x equal to 0, y equal to 0 corner hat. As we move to the right, the x coordinate increases. As we move down, the y coordinate increases. The cell to the immediate right of the top left corner is x equal to 1, y equal to 0. The upper right corner has an x coordinate equal to the width of the canvas minus 1. Most phone screens have a width around 3000 pixels, but for the sample show here, the width is 20. So the upper right corner is the coordinate x equal to 19, y equal to 0. Next, we will learn how to use the canvas, changing the appearance of the canvas in two ways, by painting on it or by placing and moving objects within it. In this section, we will learn how to change the appearance of canvas by painting on it. Each cell of the canvas holds a pixel defining the color that should appear there. The canvas component provides the canvas.drawLine and canvas.drawCircle blocks for painting pixels. We first set the canvas.paintColor property to the color we want. In the figure, we set the canvas.paintColor to red, and then call one of the draw blocks to draw in that color. In this case, we call the draw circle blocks. With draw circle, we can paint circles of any radius, but if we set the radius to 1, we will paint an individual pixel. Okay, let's explore more about the color systems. App Inventor provides a palette of basic colors that we can use to paint pixels or other user interface components. Moreover, we can access a wider range of colors by using the color numbering scheme. For more information about the screen numbering scheme, check it out at http://mit.edu/explore/ai2/support/blocks/colors.html. In addition, we will learn how to change the appearance of the canvas by placing and moving objects within it. Besides painting individual pixels, we can also place ball and image sprite components on the canvas. A sprite is a graphical object placed within a larger scene. In App Inventor, the scene is a canvas component. Both the ball and image sprite components are sprites. They are different only in appearance. A ball is a circle that has an appearance that can only be modified by changing its color or radius, whereas an image sprite can take on any appearance as defined by an image file. Balls and image sprites can only be added within a canvas. We can drag them into the user interface outside one. Next, we will learn how to animating objects with timer events. One way to specify animation in App Inventor is to change the object in response to a timer event. Most commonly, we'll move sprites to different locations on the canvas at set time intervals. Using timer events is the most common method of defining those set time intervals. Button clicks and other user-initiated events are simple to understand. The user does something, and the app responds by performing some operations. Timer events are different though, because they are triggered by the end user, but instead by the passing of time. We need to conceptualize the phone's clock, triggering events in the app instead of the user doing something. Later in this lesson, we will also discuss an alternative method of programming animation using the speed and heading properties of the image sprite and ball components. To define the timer event, we first drag a clock component into our app within the component designer. The clock component has a timer interval property associated with it. The interval is defined in milliseconds, 1,000 of a second. If we set the timer interval to 500, that means a timer event will be triggered every half second. The smaller the timer interval, the faster the frame rate of the animation. After adding a clock and setting a timer interval in the designer, we can drag out a clock.timer event in the block editor. We can put any blocks we like in this event, and they will be performed every interval. Let's move on to the next section, creating movements. Okay, now we'll learn how to create movement. To show a sprite moving over time, we'll use the move to function found in both the image sprite and ball components. For example, to move a ball horizontally across the screen, we use blocks like those in the figure on the left. Move to function moves an object to an absolute location on the canvas, not a relative amount. So, to move an object some amount, we set the move to argument to the object's current location plus an offset. Because we're moving horizontally, the x argument is set to the current x location, ball1.x, plus the offset 20, whereas the y argument is set to stay at its current setting, ball1.y. Besides moving objects horizontally, we can also move them vertically and diagonally. To move an object vertically, we modify just the ball1.y coordinate and leave ball1.x the same. If we wanted to move the ball diagonally, we add an offset to both the x and y coordinates. In the figure, for example, to move a ball diagonally, the x argument is set to the current x location, ball1.x, plus the offset 20, and the y argument is also set to the current y location, ball1.y, plus the offset 20. Next, we'll take a closer look at the speed of the object. Alright, what is the speed? Speed is how fast the object is moving. In App Inventor, The speed depends on both the setting we provide for the time interval properties of clock 1 and the parameters we specify in the move-to function. If the clock timer interval is set to 1000 milliseconds, this means that a clock 1 timer event will be triggered every second. For the horizontal movement example shown in previous section, the ball will move 20 pixels per second. But a timer interval of 1000 milliseconds doesn't provide very smooth animation. The ball will only move once per second, which will appear jerky. To achieve smoother movement, we need a shorter interval. If the time interval were instead set to 100 milliseconds, the ball would move 20 pixels every tenth of the second, or 200 pixels per second, a rate that will appear much smoother. Let's move on to the next section, collision detection. To create games and other animated apps, we need more complex functionality than just movement. Fortunately, App Inventor provides some high-level blocks for dealing with animation events, such as an object reaching the screen's edge or two objects colliding. In this context, high-level block means that App Inventor takes care of the lower-level details of determining when an event, such as a collision, occurs. We could check for these occurrences manually by checking sprite and canvas properties within clock timer events. This level of programming requires some fairly complex logic. However, fortunately, App Inventor provides them for us. And it's a good thing that it does, because these events are common to many games and other apps. We will learn how apps can detect the collision in detail later. In the next section, we will learn the edge reach detection. Consider again the animation in diagonal movement example that we have learned, in which the object is moving diagonally from the upper left to the lower right of the canvas. As programmed, the ball would move diagonally and then stop when it reached the right or bottom edge of the canvas. The system will move an object past the canvas boundaries. Edge reach is triggered when the ball or image sprite hits any edge of a canvas. This event handler, combined with the diagonal movement specified with the previously described timer event, causes the ball to move diagonally from upper left to lower right, pop back up to the upper left when it reaches an edge, and then do it all over again forever or until the app tells it otherwise. Alright, how can we distinguish between which edge what hit? The edge reach event does have a parameter edge, which specifies the particular edge by using the following code. North is equal to 1, northeast is equal to 2, east is equal to 3, southeast is equal to 4, south is equal to -1, southwest is equal to -2, west is equal to -3, and northwest is equal to -4. For example, if the ball 1 hits the north edge of the canvas, the edge code will be 1. Next, we'll learn more about collision detection in detail, colliding with and no longer colliding with events. First, we learn the colliding with event. Games and other animated apps often rely on activity occurring when two or more objects collide. For instance, a ball hitting another one. Consider a game, for instance, in which an object changes colors and plays an explosion sound when it hits another object. In the figure on the left, it shows the blocks for such an event handler. In addition, what happens when the ball 1 separates from the ball 2? No longer colliding with provides the opposite event of collided with. It is triggered only when two objects have come together and then separated. So, for our game, we might include the blocks depicted in the figure on the left. In this case, the app changes the ball one color back to blue and stops the sound. Next, we'll learn more about how to program an interactive animation. In the animated behaviors we have discussed so far, the end user isn't involved. Games are interactive, of course, with the end user playing a central role. Often, the end user controls the speed or direction of an object with the buttons or other user interface objects. As example, let's update the diagonal animation by giving the user the ability to stop and start the diagonal movement. We can do this by programming a button.click event handler to disable and re-enable the timer events of the clock component. By default, the clock component's timer enable property is checked. We can disable it dynamically by setting it to false in an event handler. This event handler stops the timer on the first click and resets the button so that it displays start instead of stop. The second time the user clicks the button, the timer enable is false, so the else part is executed. In this case, the timer is enabled, which gets the object moving again, and the button text is switched back to stop. In this section, we learn how to specify sprite animation without a clock timer. If we only want to move objects, App Inventor provides an alternative that doesn't require the use of clock component. As we might have noticed, the image sprite and ball components have properties for heading, speed, and interval. Instead of defining a clock.timer event handler, we can set these properties in the component designer or blocks editor to control how a sprite moves. If we set the heading to 0, the ball will move left to right. If we set it to 90, it will move bottom to top. If we set it to 180, it will move right to left. If we set it to 270, it will move top to bottom. And if we set it to 315, the ball will move from upper left to lower right. To cause an object to move, we also need to set the speed property to a value other than 0. The speed of the object moves is actually determined by the speed and interval properties together. The speed properties is the distance in pixels that the object will move each interval. This brings us to the last section. Finally, we'll take a look at the conclusion of this lesson. In conclusion, we learned how to use the canvas component, a sub-area of the device screen in which objects can move around and interact. There are two types of components within a canvas: image sprite and ball. Animation is an object moving, or otherwise transforming over time. We can program animation, including movement and other graphical transformations, with the clock component's timer event. Moreover, we learn how to create an animation based on the heading, speed, and interval properties internal to image sprite and ball component instead of clock timer. This presentation is based on the book App Inventor 2, Create Your Android Apps, 2nd edition by David Warburg, Hal Everson, Alan Spertus, and Liz Looney, O'Reilly Media Incorporation, USA, 2014. That's the end of this lesson. Thanks for watching.